Assalamu alaikum everyone. We are studying mechanism for addition reaction of alkenes known as electrophilic addition. This is AS level 9701 chemistry lecture video number 06. Those of you who are joining us right now, it is a must that you have to know watch the video lecture 05 and then 04 in sequence before coming to lecture video number 06. In the previous lecture video 05, we discussed the hydrobromination of ethene. Now, ethene is a symmetrical alkene. Now, what do I mean by the term symmetrical? Is that in ethene, CH2 double bond CH2, this part of the molecule is same as this part of the molecule. That means you can draw a line of symmetry which will divide the molecule into two equal halves. That means that both the carbons involved in the double bond are chemically identical. And then we studied the mechanism, and the symmetrical alkene behaves in the less complex way compared to an asymmetrical alkene. And for that matter, in order to make you understand how does asymmetrical alkene behaves, we are studying hydrobromination. We are keeping our reagent same, but of propene. Now, propene is an asymmetrical alkene. Now, what do I mean by asymmetry? If you can look at the structure of propene and you try to draw a line of symmetry over here, this part CH2 is different from this part. So that means that this carbon involved in the double bond is chemically different from this carbon which is involved in the double bond. So I hope you can see asymmetry over here. This carbon is different from this side. Now what we observe is that if we add hydrogen bromide to propene, we end up getting two different products which are structural isomers of each other. To be specific, they are position isomers. What we observe is that the pi bond once break in an anti-clockwise direction like this in the first case over here. Imagine this pi bond to be breaking like this. It shifts over here. And in the case number 2, it shifts clockwise like this. It shifts over here. Case number 1 anti-clockwise, case number 2 clockwise. So when the pi bond shifts over here, the electrophile, remember your hydrogen is your electrophile, hydrogen carries a positive charge, it's your electrophile, adds to the center carbon. If the pi bond shifts on clockwise side, the electrophile, the hydrogen bonds with your first carbon, the corner carbon. That means your nucleophile, the bromide anion, will attack the other carbon. In this case, it will attack this carbon. In this case, it will attack this carbon. We'll look into this in more detail in the mechanism. But what this means is that we'll get one bromopropane as one of the products and we'll get two bromopropane as another product. So I'll just discuss the mechanism that how this becomes possible. But another thing to learn over here will be that the one bromopropane is formed in less quantity, that's called minor product, like 25% or maybe less, something around that. And the 2-bromopropane is formed in a larger quantity, maybe 75%. So they are not formed in equal quantities in the mixture. You get this in less amount of 1-bromopropane, you get more amount of 2-bromopropane in your reaction mixture. So first I am going to focus on explaining to you that how it becomes possible for asymmetrical alkenes like propene to give you two different isomers. And then in the next part, I'll try to explain you that why one of the isomer is in lesser quantity than the other one. So this is your propene molecule. I have shifted the methyl group at the top. You can draw it over here, it doesn't matter. The reaction is similar to the mechanism for ethene of lecture number 05. The pi bond attacks the electrophile and helps in breaking this sigma bond, which simply means two things. That the pi bond can break like this anti-clockwise, which means that this carbon on the right hand side is keeping its own electron and the left side carbon is giving away its electron. And this time this carbon is becoming the carbocation intermediate. And this one is attaching with the electrophile first. This is our case number 1 over here. Another possibility is, I'm just shifting it over here. It doesn't matter if you place the hydrogens over here, because I want it to look like this in the end, that's why. And because these bonds break, the bromide nucleophile will now attack this carbon. Cross retained dot gained electrophile attached over here. The nucleophile attacks on this carbon. This results in 1 bromopropane. Now another possibility is that the bond breaks clockwise and the carbon on the left, this one, retains its own electron, and the carbon on the right, this one, gives its electron. So this one retains its electron. Over here the cross was retained, over here dot is retained, and the cross is gained from here. And it's this carbon which first binds with the electrophile, this one. And then your nucleophile, the bromide, would attack on this carbon. That means that you would be producing dot and cross, hydrogen attached to the first carbon, the bromide attached to the second carbon. So you will be producing 2 bromopropane, right? So the explanation that why the electrophilic addition of asymmetrical alkene results in 2 different isomers is because the pi bond can break and can make the bond of the electrophile with either of the carbons which are involved in the pi bond. It can break from the carbon on the left side and goes to the right side, that is an anti-clockwise direction like this one, or it can break from the carbon from the right side and goes to the left side and makes the bond with the electrophile like this one. But it is for sure that one of this is more favored, because we get this one as a major product and we get this one as a minor product. That means propene prefer to break its pi bond in a clockwise direction, that it should detach from the carbon on the right side, this one, and should be formed with the carbon on the left side like this, rather than being formed in an anti-clockwise fashion like this one. So why is that? The explanation for this will be in lecture video number 7, that why the electrophilic addition of asymmetrical alkene results in 2 different isomers, one of that is major and the other one is minor. The explanation is based on 2 different concepts. One is called Markovnikov addition. Markovnikov, it's a difficult name, Markovnikov. He was a Russian scientist, similar to Kalashnikov. And another is the inductive effect, or you can say the stability of carbocation. So I'm going to explain that in lecture video number 7. Thank you.